All right, so on the warm-up, we needed to find all the missing side lengths. We have a rectangle down here in the lower right corner of this figure. I know that the bottom of the rectangle is 12, so what other side would have to be 12 then? BD would have to be 12. DE is 9. What else would have to be 9? BF. I want to go and look at that over here where BF is, because BF is also part of this triangle here. And I see 30 degrees here. This is a right angle, so this is a 30, 60, 90 triangle. This side over here, AF, is our long leg, which is equal to the short leg times the square root of 3. AB is the hypotenuse. Hypotenuse is equal to the short leg times 2. Well, if the short leg is 9, then how big is the hypotenuse? Has to be 18. And the long leg would be 9 square root of 3. That leaves only 2 more sides that we need to find. We need to find BC, and we need to find CD. And I notice this is 45 here and 90 right here. So this is a 45, 45, 90 triangle. Which means what about the relationship between BC and CD? They do not add up to 12. They're congruent. Yes, good answer. They are congruent to each other. In a 45, 45, 90 triangle, the legs are congruent. The 12 would have to be the hypotenuse because it is opposite that right angle. So let's go figure out how big those sides are. This is the only spot where we actually have to use any kind of math that we might need a calculator for. So the hypotenuse is equal to the leg times the square root of 2. We know that that hypotenuse is 12. So we have 12 equals the leg times the square root of 2. To get the leg by itself, we're going to divide both sides by square root of 2. So that'll cancel out on the right-hand side. On the left, we're going to have to rationalize that denominator. So we multiply top and bottom by square root of 2. So in my numerator, I would have 12 square root of 2. And down in the denominator, I have square root of 2 times itself. So square root of 2 squared would be equal to my leg. Squared and square root cancel each other out. Bring my work around over here. So I would have 12 square root of 2 over 2 is equal to that leg. And then I can simplify this fraction. 2 goes into 12 6 times, so 6 square root of 2 is equal to that leg. So I can add that to my picture. 6 square root of 2, 6 square root of 2. All right. Very nice work. Go ahead and get your notes out. We're going to pick up on the same page that we left off on Friday. Friday we were on page 5 in your notes. We just started talking about sine, cosine, and tangent. And we have the acronym SOHCAHTOA that helps us remember those 3 ratios and how to set them up. So again, we have the acronym SOH, S-O-H, CAH, C-A-H, and TOA, T-O-A. The SOH tells us sine is the ratio of opposite divided by hypotenuse. CAH means that cosine is the ratio of adjacent over hypotenuse, and TOA tells us that tangent is equal to the ratio of opposite divided by adjacent. So we practiced this on number 1 on Friday, marking these relationships on the triangle they gave us off to the right. I want to do the same thing again on number 2, except we're going to do it with side lengths that are numbers instead of variables. So first one we're looking at is A. We're going to do both A and B in number 2, but I want to do just one at a time. So let's look just at angle A first. So we're going to do the cosine of A, the sine of A, and the tangent of A. So that means I need to be standing up here at angle A. So I'm going to circle that angle. After I circle the angle, I'm going to label the sides based on where I'm standing. The first side we always label as the hypotenuse. What is the hypotenuse of this triangle? 15. It's always opposite the right angle. Here's my right angle. Opposite that right angle is 15, so that would be my hypotenuse. Then we label the opposite side, and now I have to pay attention to where I'm standing. I'm standing up here at A. The opposite side does not touch my angle in any way. What is the side that is opposite angle A? 6. Right down here is my opposite side. And so by process of elimination, that means that 9 has to be my adjacent side. Cosine is adjacent divided by hypotenuse. So the cosine of angle A would be what over what? How big is my adjacent side? 9 over the hypotenuse, which is 15. Let's drop right below that one and do the sine of angle A. Sine of A, sine is opposite divided by hypotenuse. So my denominator is going to stay the same because it still has the hypotenuse in the denominator. How big is the opposite side? 6. So 6 over 15. With our trig ratios, we can leave them written as unreduced fractions. We can reduce these fractions if possible. And we can also write them in decimal form. If I were to take 9 and divide it by 15 on my calculator, I could write that in its decimal form. Your phone needs to be put away, please. We still have one more trig function to write for angle A, and that is the tangent of angle A. So this is the TOA. Tangent is opposite divided by adjacent. How big is the opposite side again? 6. Divided by adjacent. How big was the adjacent side? 'How big is our adjacent side? 9. Thank you. So 6 over 9. We're going to do the same 3 trig functions, but I want to change where I'm standing. Now, instead of standing at angle A, we're going to stand at angle B. So I'm going to redraw the triangle since I'm changing where I'm standing. So angle A is up here. C is the right angle. B is down here. CB is 6. AC is 9. And AB is 15. Now, instead of standing at angle A, we're going to stand at angle B. So I'm going to circle that angle. And then we're going to label our sides. The first side we always label is the hypotenuse. What is the hypotenuse of this triangle? Still 15. The hypotenuse doesn't move even when I change which non-right angle I'm standing at. Now I want to label the opposite side. What is opposite angle B? 9. And so again, process of elimination, this 6 right here that touches angle B is my adjacent side. So sine is the opposite side divided by the hypotenuse. When I'm standing at angle B, you guys told me which side is the opposite side? 9. Divided by the hypotenuse, which is still how big? 15. Before we go any further, I want to stop and look at something real quick. I want to look at the cosine of A compared to the sine of B. What do you notice about those two fractions, those two ratios? They are exactly the same. Yeah, 9 over 15, 9 over 15. How can that be? One of them is cosine, the other one is sine. Why did they come out to be the same? We're standing at a different angle. When I'm standing at angle A, the side that is opposite angle A is the one that is adjacent to angle B. So the sine of one angle is going to be exactly the same as the cosine of the other non-right angle in that triangle. All right, let's do tangent next. Tangent of angle B. Drop right down there. TOA, tangent is opposite divided by adjacent. How big is our opposite side again? 9. And the adjacent side? 6. Look at this other interesting thing that just happened. The tangent of A was 6 over 9. The tangent of B is 9 over 6. When I change the angle that I'm standing at in this right triangle, when I change to the other non-right angle, what happens to my tangent? Yes, it becomes the reciprocal. Again, when I change which angle I'm standing at, the opposite and the adjacent switch because my position has switched, so the tangent is going to flip over. It's going to be the reciprocal. All right, last one on number 2. Cosine. Cosine is the relationship of which two sides? Adjacent over hypotenuse. And how big is our adjacent side? 6, and then hypotenuse is 15, so 6 over 15 for cosine of angle B. Whenever I'm asked to go through and do it from both angles, I redraw the picture for my second angle, and I label those sides again. Right. We are going to use sine, cosine, and tangent to find some missing sides in non-special right triangles. We're going to write down the steps that we use to solve those, and then we're going to try 3 examples there. So on these lines down here, steps for solving non-special, so not 45, 45, 90, not 30, 60, 90, non-special right triangles. First thing we're going to do is we're going to locate the angle where we are standing. So we're going to circle the given angle. When we're looking at these non-special right triangles, we are usually only given one angle other than the 90-degree angle. We're going to circle that. It's going to become an essential part of our ratio. After we circle the angle, then we're going to label the sides. When we're labeling the sides, always label the hypotenuse first. Then we're going to label the opposite side second. And last, we will label the adjacent side. We label the hypotenuse first because the hypotenuse is always going to be across from that right angle. Even if I go stand at the opposite angle, the hypotenuse will not move. So we circle our angle, we label the sides, then we set up the ratio and solve. circle our angle, label our sides, set up our ratio, which means we're going to have to decide which trig ratio is going to be used, and then we will solve it. All right, let's try this. So number 3, part A. We have the right angle, and then we have one other angle. What is the angle that's not the right angle in 3A? 50 degrees. So we're going to circle that 50-degree angle here. We are standing up at this angle. After we circle the angle, we're going to label our sides. First side we always label as which one? Hypotenuse. What is the hypotenuse of this triangle? 17. So here's my hypotenuse. Then we label the opposite side, and I have to pay attention to where my circled angle is. The opposite side will never touch my circled angle. What is the side that is opposite 50 degrees? X. So here's my opposite side. So this one up at the top that doesn't have any variables or any numbers or anything, which side would that be then? Adjacent. Even though there's no numbers and no variables there, I'm still going to label it. Always label hypotenuse, opposite, and adjacent. Now we have to decide which trig function we're going to use. So I'm going to write down SOHCAHTOA. And up at the top, that adjacent side up here, this was the side that we didn't have any variables, we didn't have any numbers there. So I'm not going to be able to use the adjacent side at all to help me solve this triangle for x. So that means any of my trig functions that use the adjacent side, like cosine or tangent, I'm not going to be able to use these because I don't have that adjacent side. So we're going to use the sine function. So now to set up the ratio, the first thing we do is write down the name of the function that we're going to be using. We're using sine. And then inside parentheses, we put the angle. How big was that angle again? 50 degrees. Don't forget the degrees symbol. It is really important. If you leave the degrees symbol off, it has a very different meaning with a very different answer. And then I see O over H. O stands for opposite. How big is that opposite side? X. Over the hypotenuse. How big is the hypotenuse? 17. Now we want to isolate X. We want to get X alone. X is part of a fraction right now. We talked a lot in the last module about how to get rid of fractions. What operation gets rid of fractions? Multiplication. And what part of the fraction do you always have to multiply by? The denominator. What's in the denominator of this fraction? 17. So we're going to multiply by 17. And if you do it to one side, you have to do it to the other side. So on the right, that cancels those denominators out. On the left, I have 17 times the sine, parentheses, 50 degrees is equal to x. And now, we're going to pull out our calculators. This is where those yellow calculators come in. So we're going to put this all into our yellow calculators. First thing I want you to double check on your calculator is that up at the tippy top in itty bitty letters, you should see DEG. If it says RAD, you're in the wrong mode, and I can show you how to change that. You want to make sure that it's DEG. If you're using a calculator different than my yellow ones, it might just have the letter D up here. If you see the letter R or RAD, it's in the wrong mode, and it will give you the wrong answer. So once you make sure it's in degrees mode, that's what the DEG stands for, we're going to type in exactly what we see right here. 17 times sine, and then it'll open up parentheses for you, and you're going to put the angle in those parentheses. 50, close the parentheses, and hit enter. What do you get when you hit enter? 13.022 or 023, depending on how you round that. All right, let's try another example. Part B, first thing we do is circle the given angle. What is the given angle on part B? 32 degrees, so that's what we're going to circle. We are standing here at the 32-degree angle. Then we label our sides. Which side do we always label first? Hypotenuse. Where's the hypotenuse in this triangle? It's at the bottom, right here. Then we label which side? Opposite. What is opposite 32 degrees? 9. And so my adjacent side would have to be which one? Adjacent side has to be x. We need to figure out which trig function we're going to use, so we write down SOHCAHTOA. Which of those three sides do we not have any information about? H, the hypotenuse. So we're not going to be able to use any of the functions that use the hypotenuse. Which functions use the hypotenuse? Sine and TOA uses the hypotenuse? Cosine. That got all messed up there. We can't use anything that uses the hypotenuse because we don't have the hypotenuse. So we're going to have to use tangent. So tangent, and then inside parentheses, we put our angle. What is our angle? 32 degrees. Close those parentheses. And then I need opposite divided by adjacent. What is the opposite side? 9. And the adjacent side? X. X is part of a fraction. We always use multiplication to get rid of fractions. And we multiply by what part of that fraction? Denominator. This denominator is x this time. So it cancels out my denominator over on the right. On the left, I have x times the tangent of 32 degrees is equal to 9. Do I have x all by itself now? No. What operation is going on between the x and the tangent? Multiplication. How do we undo multiplication? With division. If you do it to one side, you have to do it to the other side. So we're going to divide both sides by the tangent of 32 degrees. So now into my calculator. I'm going to type in exactly what I see here. 9, and then the division key, tangent, 3, 2, close the parentheses and hit enter. What do you get when you do that? 14.403. Last one. We have just enough time to finish up this last one. Circle our given angle, which is where? 29 degrees. Then we label our sides. Hypotenuse first. What's the hypotenuse? 10. Then my opposite side, which is over here. And the adjacent side would have to be what? X. We're going to decide which trig function to use. So, ka, toa. Which side do we know nothing about? Opposite. So that means we can't use which functions? Sine and tangent, because we don't have the opposite side. So that means we're going to use cosine. So COS, and then what do we put in parentheses? 29 degrees. Thank you. And then I need adjacent over hypotenuse. How big is the adjacent side? X. And the hypotenuse is 10. We want to get the x all by itself, so I need to multiply by what? 10. So we multiply both sides by 10. Into my calculator, I do 10 times cosine 29 degrees. What do you get when you put that in the calculator? 8.746. Very nice work. Cell phone calculators technically can do sine, cosine, and tangent. However, the way you type it in is very different, and sometimes it's actually quite difficult to do on a cell phone calculator. So I would recommend using my yellow calculators. That means when you're working on the homework, get your ratios set up. And if you don't have a calculator like the yellow one at home, first thing you do when you come into class is grab one of those yellow calculators and type it in there. The homework that you guys picked up on your way in the door is due on Wednesday this week. Tomorrow, we're going to talk about how to find missing angles using sine, cosine, and tangent.